Number 11. As I read this line that stands out to me, line now passes through, right? It's going to own this point, this 5, 3. And they're giving me a condition. Our line now needs to be parallel to some other line, which they're calling K. And they're going to tell me its equation is 5x plus y equals 6. And their question is, hey, what is the equation of that line L that meets these two conditions? Right? Not only do you have to be parallel, you've got to own or possess. In other words, you have to pass through that point 5, 3. And when I hear parallel lines, what comes to mind is equal slopes, but different y-intercepts. Okay, so I need to find what the slope is, and I can find that out by looking at my original line and looking at that slope. Because whatever this slope is, my parallel line will have the same exact slope. So if I go and write out the equation of the original, 5x plus y equals 6, and remember, I want to solve this for y equals. So I can look at the m, which is next to the x, and the b. I'm interested in solving for y. I'm interested in getting rid of 5x because when I'm done, I want this to look like y equals my minus 5, and then the x should it doesn't have to come first, but it should, just so we don't make a mistake. It's resembling that form. And then we're going to stick this constant, that 6, at the end. And that 6 was a positive. That's how I know it's a plus, positive 6. So when I look at the original, I know my original slope is minus 5. And my original b value is 6. But this is the slope that's going to carry over to the parallel line. The parallel line, the parallel slope, is going to be minus 5, and our parallel y-intercept is a big question mark right now. But we can use this equation, the equation of any line, to help us figure out what our y-intercept is. Because the y-intercept is the variable we're going to look for. Because if we think about it, I know my m value. I know my m value needs to be minus 5. Okay? Not only do I know my m value, I know my x value, because my line has to go through this point 5, 3. That x and that y have to belong to my line, has to belong to this equation. So wherever I see an x, I'm allowed to put 5. And that was multiplication, so I'll toss in the 5. I'll tack on that plus b, throw in my equal sign. And the same thing goes for this 3. Right? That's the y value of the point that belongs to my line. So wherever I see a y, I'm allowed to put 3. And now I've got an algebraic equation that I can very easily, or using algebra, I can solve for b. So I've got nothing to do on the left side of my equation. I'm going to do this multiplication. Negative 5 and a positive 5 is a negative 25 plus b. I'm going to add 25 to both sides. And it's going to be 28 equals b. My y-intercept is going to be 28. So, 28. I've got all the information I need to write the equation of a line. It will be y equals my slope, that minus 5 times x, plus my y-intercept, which is plus 28. I know you might be saying, hey, that looks weird. That's a strange y-intercept. But, take that as a sign. You should probably check your work. But that's totally reasonable. It's possible. And I can kind of test this out. I can use GeoGebra and we can test and see if that really is our answer. But yeah, take that as a little hint, like maybe I should do some double checking. And if you buy the answer, great. I'll see you in the next one. But if you want to see what's really going on, we can check it. So our original line was that 5x plus y equals 6. 5x plus y equals 6. There's that line. It's saying the parallel line goes through the point 5, 3. So I'm going to graph that point 5, 3. And GeoGebra is awesome because I can, make a parallel line by clicking the original line to get the slope, and I can just stick it through point A. And I can see, yeah, that y-intercept does go through 28. And if you look at the equation, turn it into y equals, our answer of y equals minus 5x plus 28 is exactly the equation of the image, the parallel line that passes through the point 5, 3.